Good morning, everyone. We are the Group 3 and we will be tackling the conic section ellipse.
So what is an ellipse? An ellipse is the set of all points P, the sum of whose distance from two specified points f sub 1 and f sub 2 is a constant number. The point f sub 1 and f sub 2 are called foci or focus.
Note that in ellipse, there are two axes of symmetry, the major axis, which is the longer axis, and the minor axis, which is the shorter axis. The vertex or the vertices of an ellipse is the endpoint of the major axis, while the co-vertex or the co-vertices is the endpoint of the minor axis of an ellipse. The center of an ellipse is the midpoint of both the major and the minor axes. The axes of an ellipse are perpendicular at the center, and its foci always lie on the major axis. And the sum of the distances from the foci to any point on the ellipse, or the constant sum, is greater than the distance between the foci.
So the graph you see in your screen, that is the graph of ellipse or elliptical shape. In ellipse, you will also encounter the major axis or the longest diameter. So, from the vertex to another vertex of our ellipse, that is the major axis. We also have the minor axis or the shortest diameter. From the co-vertex to another co-vertex, that is the minor axis. We have the semi-major axis. Semi-major axis, that is the half of the measure of the major axis. So, from the vertex to center point, mauna ang semi-major axis. So that means the measure of that is A. And also, we have the semi-minor axis, half the measure of our minor axis. So, from the co-vertex to the center point, that is the semi-minor axis or B. Ang C kay C is the distance of the center going to the foci or focus. So, those are the terms, mathematical terms that you are going to encounter in ellipse. There are two forms of standard equation of an ellipse centered at 0, 0, depending on whether the major axis is horizontal or vertical. Standard form of equation of an ellipse centered at 0, 0. The major axes are horizontal and vertical. The equation for the horizontal is x squared over a squared plus y squared over b squared is equal to 1. And for the vertical, x squared minus b squared plus y squared over a squared is equal to 1. For the foci or focus, negative c and 0 and c, 0 for the horizontal. For the vertical, 0, negative c, and 0, c. The relationship of ABC is c squared is equal to a squared minus b squared, both horizontal and vertical. Most na siya ang formula sa C. Length of the major axis, 2a, both horizontal and vertical. Length of the major axis, 2b, both horizontal and vertical. The vertices of horizontal are negative a, 0, and a, 0. For the vertical, 0, negative a, and 0, a. For the co-vertex of horizontal, 0, negative b, and 0, b. For the vertical, negative b, 0, and b, 0. You can write the equation of an ellipse when you are given the coordinates of the vertex and foci.
In order for us to visualize our formula, we need to have some examples. Write the equation of the ellipse shown in the graph. By the way, let's not forget that our A is classified as our major axis, B is classified as our minor axis, and our C is classified as our foci. An ellipse has two axes of symmetry, the longer one called the major axis and the shorter one called the minor axis. In our graph, we can already identify which among the two lines is our major axis, which is our horizontal line, since it lies along with our x-axis. And of course, it has the longer distance, so automatically it will be our major axis. Our ellipse here has a horizontal major axis. And the first thing we need to do is to find the length of our major axis. In the graph, the coordinates of the vertices that lie in the major axis are -7 and 0 and 7, 0. So the length of our overall major axis is equal to 14. So the equation would be like this. 2a is equal to 14. In order to get a, let's divide both sides by 2 and our a would be 7. From our graph, the indicated foci is -6 to 0 and 6 to 0. So automatically our C or our foci would be 6. Now that we already find those two values from our A and C, let's continue on finding our B through using this equation. C squared is equal to A squared minus B squared. Let's substitute C by 6 and A by 7. 6 squared is equal to 36 and 7 squared is equal to 49. Let's subtract 49 from both sides of the equation, and our b squared would be -13. Since we need to eliminate negative sign from our b squared, let's multiply both sides by -1. So our b squared now would be equal to 13. We can now use standard equation of ellipse with horizontal major axis. X squared all over a squared plus y squared all over b squared is equal to 1. Now everything is ready. Let's do the substitution. Let's substitute a by 7 and b squared by 13. Since we haven't simplified our a, let's square 7. So this is our simplified standard equation of ellipse with a horizontal major axis. X squared all over 49 plus y squared all over 13 is equal to 1. We can now proceed on to our example 4 standard equation of ellipse with a vertical major axis. Write the equation 7x squared plus 3y squared is equal to 63 in standard form and sketch a graph of the ellipse. 7x squared plus 3y squared is equal to 63. To transform this particular equation, let's divide both sides by 63. 7x squared all over 63 would be x squared all over 9. 3y squared all over 63 is equal to y squared all over 21. 63 divided by itself is equal to 1. So our simplified standard equation would be x squared all over 9 plus y squared all over 21 is equal to 1. Let's now find the values of our A, B, and C. On our equation, the longer value indicated is 21. So, we will use 21 as our A, our major axis. To find A, let's square 21. So, our A would be 4.58. For our B, or the minor axis, since the shorter value indicated on our equation is 9, let's use 9. 9 squared is equal to 3, so our B would be 3. Let's proceed on to finding our C by using this equation. C squared is equal to A squared minus B squared. Let's substitute 21 by A and 9 by B. 21 minus 9 is equal to 12. To find C, let's square 12. So our C would be 3.46. Now that we already find those three values, let's now proceed on to plotting our graph. Let's use 4.58 as our major axis that lies along with our vertical line or our y-axis. 3 for our minor axis that lies along with our horizontal or our x-axis. 3.46 for our foci that lies inside our vertical line or our y-axis. We can now write all the values that we can see on our graph. For our foci, from the center 0 to negative 3.46 and from the center 0 to 3.46. Vertices from the center 0 to negative 4.58 and from the center 0 to positive 4.58. Last, for our co-vertices, from negative 3 to our center 0 and 3 to our center 0.
So we are done discussing the ellipse whose center is at the origin. Now we will discuss the ellipse whose center is located at the particular point each k. For ellipse with a center at each k with major axis parallel to the x-axis, these are the important informations we need to learn and understand. So the equation of the ellipse whose center at each k is quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1, which is a is greater than b. For its foci, we have h minus ck and h plus ck. To get the value of a, b, c, we're going to use the formula c squared equals a squared minus b squared. For the length of major axis, we have 2a, and for its minor axis, we have 2b. For the vertices, we're going to use h minus ak and h plus ak. And lastly, for its co-vertices, we have h k minus b and h k plus b. So to understand more, let's have an example. So example, sketch a graph of the ellipse using the equation quantity x minus 5 squared over 8 plus quantity y plus 3 squared over 2 equals 1. So since the denominator of x squared is larger, which is 8, the ellipse has a horizontal major axis. So before we start getting the center, foci, vertices, and co-vertices of this equation, let us identify first what is a squared, b squared, a, b, and c so that it will be easier for us to do the next step. Looking at our equation and based on the standard equation of an ellipse, we can tell that a squared equals 8 and b squared equals 2. Then, to get the value of c, we're going to use the formula c squared equals a squared minus b squared. So, c squared equals 8 minus 2. C squared equals 6. So, we're going to get the square root of c squared and the square root of 6. So, now we have c equals plus minus square root of 6, or c is equal to 2.45. And now let's move on to the next step, which is to get the center, foci, vertices, and co-vertices of this equation. So looking back at our equation, since we have x minus 5 and y plus 3, the center of the ellipse would be 5 and negative 3, which is h is equal to 5 and k is equal to negative 3. Next is the foci. So remember that c is equal to 2.45. So to get the foci, we're going to use h minus ck and h plus ck. So we're going to substitute h to 5, c to 2.45, and k to negative 3. So we have 5 minus 2.45, negative 3, and 5 plus 2.45, negative 3. So kung i-simplify, we have the foci 2.55, negative 3, and 7.45, negative 3. Then, we have the vertices of major axis. Remember that A equals 2.83. So, we are going to use H minus AK and H plus AK. So, kung i-substitute, we have 5 minus 2.83, negative 3, and 5 plus 2.83, negative 3. So, kung i-simplify, the vertices of major axis are 2.17, negative 3, and 7.83, negative 3. And lastly, we have the vertices of the minor axis or the vertices. So, remember that B is equal to 1.41. So, we are going to use h k minus b and each k plus b. So substitute again. So we have 5 negative 3 minus 1.41 and 5 negative 3 plus 1.41. So kung i-simplify, we have the covertices 5 negative 4.41 and 5 negative 1.59. Since we're done getting the center, foci, vertices, and covertices of the equation, now we're ready to sketch the graph. So, this is the graph of an ellipse that has a horizontal major axis. So, as you can see, this is the center, which is 5 and negative 3. The focus 1, which is 2.55, negative 3. The focus 2, which is 7.45 and negative 3. The vertices, we have first the 2.17, negative 3, and 7.83, negative 3. Lastly, we have the covertices, which is 5, negative 1.59, and 5, negative 4.41. So, that is the final graph of an ellipse that has a horizontal major axis. Using the equation quantity x minus 5 squared over 8 plus quantity y plus 3 squared over 2 equals 1.
Since Miss Ria is done discussing the standard form of a horizontal major axis of an ellipse centered at h, k, so now let's proceed into an example of a vertical major axis of an ellipse centered at h, k. So here are somewhat the formulas or the basis in getting the standard form of a vertical major axis of an ellipse which is centered at h, k. So in getting the equation, we must use the quantity x minus x squared over b squared plus quantity of y minus k squared over a squared equals 1, in which a is always greater than b. And in foci, we will use the h, k minus c and h, plus c. And in getting the a, b, c, we will use the formula of c squared equals a squared minus b squared. And in getting the length of the major axis, we will use the 2a. And in the length of the minor axis, we will use the formula of 2b. And in getting the vertices, we will use the formula h, k minus a and h, k plus a. Co-vertices, we will use the h minus b, k and h plus b, k. For example, write the equation of an ellipse in the standard form if the vertices of the ellipse are 2, 19 and 2, negative 7 and the co-vertices are negative 3, 6 and 7, 6. So given in the left side the given vertices and the co-vertices, always as well as the unknown values that we need to find out. So first, let's find out the center or the h, k. So to find the h, k, we will use the midpoint formula, which is m equals x1 plus x2 over 2, y1 plus y2 over 2. Based on the values of vertices in the left side, we will use it to substitute to the midpoint formula. So we come up with the m is equals to 2 plus 2 over 2, 19 plus minus negative 7 over 2. And then let's simplify. So we came up with m is equivalent to 2, 6. So therefore, our centered h, k is equivalent to 2, 6, wherein our h is equivalent to 2 and our k is equivalent to 6. Since we already have the value of center, let's proceed in finding the value of a and b, or the length of the major and the minor axis. So to get the value of a, first we will use the y-coordinates of the vertices to solve the major axis. So 19 minus negative 7 is equal to 26. Then using the formula of 2a equals 226, we simplify it using the division property of equality by dividing both sides by 2. So 2 divided by 2 is cancelled out, a is bring down, and 26 divided by 2 is equivalent to 13. So our a now is equivalent to 13. And to find the length of the horizontal axis, we will subtract the x coordinates from the co-vertices. So 7 minus negative 3 is equivalent to 10. So, and then 2b is equivalent to 10. And using the division property of equality, we divide both sides by 2, and divided by 2 is cancelled out, and b is bring down, and 10 divided by 2 is equivalent to 5. So our b now is equivalent to 5. So our a is equivalent to 13 and b is equivalent to 5. So now, since we already have the value of a and b, let's proceed in getting the value of c. So using the c squared equals a squared minus b squared formula, we will get the c by substituting the value of a and b. So c squared is equivalent to 13 squared minus 5 squared. And let's simplify. C squared is equivalent to 169 minus 25, and 169 minus 25 is equivalent to 114. And in order to get the c, we need to square root the 114. And the square root of 114 is equivalent to 12. So therefore, our c now is equivalent to 12. So now let's proceed in solving the two focus. The first focus is equivalent to h comma k minus c, and we just substitute the values using the values in the given and the known values in the left side. So we have 2 comma 6 minus 12, and we simplify it and we get the focus is equivalent to 2 comma negative 6, and the focus 2 is equivalent to h comma k plus c, and we also substitute the values given in the left side. So we get the focus is equivalent to 2 comma and 18. Since we already know the unknown values, we will now proceed in solving the standard equation of ellipse with vertical major axis using the quantity of x minus h squared over b squared plus quantity of y minus k squared over e squared equals 1. And then let's substitute these values that given in the blue table at the left side to this equation. So now after substituting, now we get the quantity of x minus 2 squared over 5 squared plus the quantity of y minus 6 squared over 13 squared equals 1. And now we simplify it to get the standard equation. And then we get the quantity of x minus 2 squared over 25 plus quantity of y minus 6 squared over 169 equals 1. And that's it. The quantity of x minus 2 squared over 25 plus the quantity of y minus 6 squared over 169 equals 1 is the standard form or the standard equation of an ellipse with vertical major axis that is not centered in its origin. And since we already know the known values that needed in this graph also, we can graph this equation now. And here in the left side, we can say the coordinates that needed in our graph, and alongside with the color of points that points out which of those points in the graph they are. So the blue one is the centered or the HK, and the black one are the foci, and the green one are the vertices, and the co-vertices are the violet ones. And that's it. And that's all, everyone. Thank you for listening. And that's the end of our discussion about ellipse. And thank you for listening, everyone. And bye-bye.